Another 3 days have elapsed, so it is time for the next episode of Spaceflight News, in which we summarize the 3 most noteworthy events of the preceding days. To begin, we will take a look at a footage from the International Space Station as it orbited above the Hurricane Idalia. Next, we will turn our attention to the Moon, where Indian Chandrayaan 3 spacecraft detected sulphur. Lastly, we will behold the M51 galaxy as captured by the James Webb Telescope. The International Space Station serves as a unique scientific laboratory, enabling research in a variety of fields. Moreover, it also plays an important part in remote sensing of the Earth. Astronauts often utilize cameras to photograph the Earth's surface, but our planet is also constantly observed by specialized instruments located outside the station. Recently, conventional cameras, primarily used for monitoring the station's exterior, captured an atmospheric phenomenon occurring on Earth. This footage was taken on August 30th, just hours after Hurricane Idalia struck Florida. It brought strong winds and heavy rain to the southeastern US. It is images like this from high altitude that perhaps best show the sheer scale of this devastating phenomenon. The International Space Station orbits the planet at an altitude of about 420 kilometers. The cameras used for this recording certainly don't have a narrow field of view, yet Hurricane Idalia often fills much of the frame. American spaceflight was also affected by the hurricane. Although spaceports on Florida were not directly struck, the hazardous conditions prevented a safe launch of the ULA's Atlas V rocket with the classified mission Enroll 107 Silent Barker. As a precaution, the launch vehicle was not left on the launch pad. Instead, it was returned to the Vertical Integration Facility. Both the Indian rover Pragyan and lander Vikram, which landed on the Moon as part of the Chandrayaan 3 mission, remain operational. Numerous photographs from the lander and the rover, as well as videos, have already been transmitted to Earth. In this one, we can see the Pragyan rover rotating to proceed in a different direction. Furthermore, the first scientific data has been transmitted to Earth as well. The Indian Space Agency ISRO, for instance, published this graph. These are measurements from the LYBS laser spectrometer on the Pragyan rover. What has likely elicited the most attention is the presence of sulfur in an acquired sample. Scientists did not anticipate detecting this element on the lunar surface. The confirmation that this was not an error was soon received when the presence of sulfur was verified by a second instrument on the Pragyan rover, the APXS spectrometer. Both readings have thus raised a number of questions to which we do not yet have answers. Scientists are wondering how the sulfur could have arrived there. Has it always been there, or was it transported to the Moon by meteorites, or is it a vestige of ancient volcanism? In addition to the sulfur already mentioned, the measurements revealed other elements: aluminum, calcium, iron, chromium, titanium, magnesium, silicon, and oxygen that were expected to be present. Meanwhile, the search is still ongoing for hydrogen, which could indicate the presence of water. Further data is still to come, and it will take some time to analyze it. But it is already evident that the Chandrayaan 3 mission is not only of technical, but also scientific significance. And this is a photograph from the Pragyan rover depicting the Vikram lander. The photo distinctly displays the lander taking measurements of the thermal conductivity of regolith using the chased instrument. The yellow circle indicates the ILSA instrument laid out to measure seismic activity. The lander and rover still have about a week of service remaining. After that comes a 14-day long lunar night, which their electronics will probably not withstand. After quite a long time, let's take a look at the beautiful photographs taken by the James Webb Space Telescope. This image is of the galaxy M51, captured by NIRCam in the near-infrared spectrum. And this is the same area captured by the MIRI instrument, which is sensitive to the longer mid-infrared wavelengths. M51 is located approximately 27 million light-years away from Earth in the constellation of Canes Venatici. Its shape is affected by the gravitational pull of the neighboring dwarf galaxy NGC 5195. Scientists utilized the James Webb Telescope for the observations of M51 as part of an observation campaign known as FEAST, Feedback in Emerging Extragalactic Star Clusters. As part of the campaign, astronomers are studying the processes that influence the rate of star formation. These data are thus of paramount importance for creating accurate computer models that are used to simulate the evolution of the universe. Prior to the launch of the James Webb Telescope, these observations were conducted using ground-based observatories, but this had its drawbacks. For instance, due to the Earth's atmosphere absorbing infrared radiation. The Webb Telescope has thus opened up unprecedented opportunities for scientists around the world to make highly precise observations. We thank you for your attention to today's episode of Spaceflight News. You can expect the next episode on Sunday, September 3rd, and in the meantime, follow our Twitter for more space news, as well as links to new episodes. You can find the link in the video description.